So let's start taking a look at these questions and see what we can do with them. The big thing here that I want you to do is I want you to have a scrap piece of paper beside you, just like I put up a scrap piece of paper here. I'm going to do 3 questions in a row just based on the equation. Let's see if we can apply everything that we've learned so far into this situation, okay? Goodski, 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 let's go. First thing that you should notice, yeah, we got to take this thing right here and we got to go out and factor it. So GCF tells us take out an X, leaves us with an X plus 5. On the bottom, hey, I can factor that from inspection. Why? Because I'm smart. Okay, that would be X plus 2 and X plus 5. Okay, now let's do some work here. Let's figure out the vertical asymptotes. Let's figure out if there's a point of discontinuity. Look at that. We have something that cancels. Automatic tells you that that is a point of discontinuity. That's going to be a hole in the graph. But where? Well, that's going to be a hole in the graph at x equals to minus 5. Of course, because it's the x plus 5 that was eliminated. So I'm going to put a point of discontinuity right there. I'm going to say it's a minus 5 comma something. We don't know what that is yet. So let's finish it off. Let's take this minus 5 and just put it back in. So this will be minus 5 over minus 5 plus 2. That'll give me minus 5 over minus 3. So guess what? That'll give me a nice little point of discontinuity at 5/3. So minus 5, 5/3. There's my hole in my graph. Done. Okay, now let's go back and let's do a little bit more. I'm going to get rid of this point of discontinuity now because I figured that out. And plus, I need some space to write in. Here, vertical asymptote. Guess what? There's your non-permissible value, your NPV, which of course results in your vertical asymptote. So your vertical asymptote, your NPV is x cannot equal to -2. You know and I know that your vertical asymptote is x equals to 2. So guess what? Oh, x equals to -2. Ooh, almost messed up on there. X equals to -2 is your vertical asymptote, brought to you by the guy that didn't cancel out. Okay, now let's go over to our horizontal asymptote. Okay, so let's clean this guy up again. Ba-da-da-da-da-da-da-da-da. And as a matter of fact, I'm going to take this guy and I'm going to actually write the resulting equation, which is x over x plus 2. Do you remember the horizontals, the ha-ha-has? Well, take a look. There's your x values. Guess what? Those two match. And if you remember, the coefficients up front are 1 and 1. So the highest powers that are left, you match them up, you take a look at them, and you realize that it's 1 over 1. So guess what? Your horizontal asymptote will be at y equals to 1. Oh my goodness, this is so cool. Now, let's do the x-intercepts and y-intercepts now. Okay, piece of cake. Go back to your original question right over here, okay? And remember that this guy, in fact, was a y equals 2, right? Okay, so let's find out our x-intercept. X-intercept happens when y equals to 0. Now, you know and I know, wait a second. You know and I know that if I let this equal to 0, look what happens to the equation. This is x over x plus 2, right? You know and I know that we can go like this over 1. We can cross multiply that guy right there. We're going to have 0 times x plus 2. You're going to have x equals to 0. Oh my goodness gracious me. Of course, the x-intercepts are based on the guys in the numerator. Oh, of course, our x-intercept then is x equals to 0. But how about our y-intercept? Let's see what we can do with that puppy right now. Okay, piece of cake. X-intercept, y equals to 0. Y-intercept, guess what? X equals to 0. Yeah, of course. Remember our equation? Y equals to x over x plus 2. If we let x equal to 0, take a look what happens. That means this guy is now 0. So you got y equals to 0 over this guy being 0 over 2. Oh, hey, look at that. 0 divided by 2 is 0. So guess what? Your y-intercept happens at, 0. So now, let's figure out our domains and ranges now. Look how we're doing all of this without even graphing the thing because we're using our brain. I like my brain. My brain works nice. I like it. Okay, think about it. What are your non-permissible values? Your non-permissible values, of course, x cannot equal to minus 2, but don't forget that you took this guy right out. You got rid of him. It's like saying that that's a non-permissible value as well because it is in the denominator, even though you've canceled it out. It is your point of discontinuity. So guess what? You have to also include the minus 5. So if you're going to do this technically really nice and pretty, you go, oh, all the values of x such that x cannot equal to minus 2 and minus 5, but all the other x's are an element of the real numbers. So you can have any other number as long as it's not minus 2 and minus 5. How did you get them? Of course, our non-permissible values. Our range then, wait a second. We have to have a range as well. Well, you know and I know the range is based on the horizontal asymptote. So guess what? Y cannot be 1. But what about the other one? Point of discontinuity. Look at this. The y can also not be 5/3 based on that point of discontinuity. Okay, so what's your range? Real simple. All the values of y such that y cannot equal to, guess what? 1 and 5/3, but y can be any other real number. Oh, baby, look at that. That's how you do these things. And folks, stay tuned. We got 2 more podcasts coming at you doing exactly the same thing.